Part 2. So now that we've already set up the equation for y, the temperature of the object at time t, which is what we have here. So now all we have to do is figure out what the question is now asking us to do, and we can solve the problem here. So what was the temperature of the object 15 minutes after it was 30 degrees? Okay. Well, since we have our equation and we're being asked what was the temperature, well, the part about what was the temperature, and you should be evaluating this or interpreting this to mean what is y of, so 15 minutes, so what is y of 15? That's what that is saying. What was the temperature of the object 15 minutes after it was 30 degrees? And remember, after the 30 degree part was that's y of 0. Okay, so then all we have to do is calculate y of 15. And y of 15 is 20 plus 10 times e to the k times 15. And now if you're plugging this into your calculator, great, you can do that. Yeah, if you're not, you can't really do anything else. So let's do that. Here's a little trick. You might be using this formula again. And in most cases, in an FRQ, you're going to use the formula again. So you might as well plug the formula into your y1. So you can type this in as 20 plus 10 times e to the what? Okay, well, to the what would be, remember our alpha a is where we stored the k, and then x is what we're going to use as our variable. So that will show 20 plus 10 times e to the k, which is in our calculators a, times x. Okay, and we're going to go ahead and enter, quit that screen, and we want our y at 15. So we can just find our y1 and type in 15, and we get 27.092. Now what does that mean? And that means, let's just make sure, 27.092 what? Temperature. So look back at what the temperatures, how they are listed. We have 30 degrees Celsius, so this would be 27.092 degrees Celsius. Okay, so that's part A. Part B, this is how long. So this, you should be interpreting this to mean how long, so that we want T. We want T when what? How long will it take the object to cool down to 21 degrees? So T when y of t is equal to 21. Okay, so we know our equation, y of t, can you see it? No, you can't even see it, sorry. So we know our y of t is equal to 20 plus 10 e to the k t. And when y of t is 21, so we replace y of t with 21, we get 20 plus 10 times e to the k t, and we just need to solve this equation for t. So we're going to subtract 20 from both sides, we get 1. Subtract 20, we get 1 equals 10 e to the k t. Divide both sides by 10. Don't get log crazy here and divide or try to convert this to logs before you get that e by itself on the right side. So a common mistake as well. So let's let that be 0.1. And so we're going to take the natural log of both sides, or you could think of this as converting this exponential statement to a log statement. But nevertheless, we get ln of 0.1 equals k times t. And if we divide both sides by k, I'm doing this in green here, so we're going to divide both sides by k, and we get ln of 0.1 over k equals t. And so just plug that in, get ln of 0.1, divide that by our k, which is on our calculator's a, so it's 100.518. Okay, so we get t is approximately equal to 100.518. And what is that? So how long? So we need, don't put degrees Celsius, I've seen that before. This is in minutes because that's what all of the units have been given in. So this would be minutes. So how long will it take the object to cool down? That would be 100.5 518 minutes. And if it said convert to hours, you could do that as well. So we'll leave it like that because it didn't specify. And congratulations. See you in the next video.